Hi there, welcome to this video on slope fields. This should be Unit 7 if you are taking AP Calculus, and we're going to go ahead and get an introduction into what are called the differential equations, starting out very basic with a concept called slope fields. So that is what we are learning in this video. Let's start with a function f of x, which is shown here, and what we're going to do is sketch small segments of tangent lines of the graph at several values of x. And the ones that we generally will target will be values of 0, as those are the easiest. So we can go ahead and look at our extrema. So like right here I have a slope of 0. And the other ones usually are like positive 1, so like maybe right around here would have a slope of 1, and maybe like right here a slope of 1, and then maybe right here this is a downward slope of -1. So at all of these values, right, we have slopes. Those are the individual slopes, right, at that specific point. That's the whole idea of calculus, instantaneous rate of change. This is the idea behind slope fields. If we only have a glimpse of the slopes of a function, we can understand how a function behaves or moves, even sketch a picture or what we call a solution curve, which is a very specific curve to a differential equation, because it is possible. Actually, we can have infinite solutions to a given slope field, and we'll talk about that in a second. A slope field is a graph of the slopes of a given function at various points. Generally, we'll be given a differential equation, and we'll ask to do one of two things. The first one, which is the most common, is they'll give you a slope field and they'll ask you to sketch, that's the least common one. Sketch a slope field at various indicated points. I think the most they will ask of you is like 16 points, and I'll show you this here in a second. And you just have to sketch a slope given a differential equation, which is pretty easy. Or number 2, sketch a solution curve through a given point on a given slope field. So they'll give you a slope field and you just draw a curve through it. That's the most common, okay? So we'll look at both of those situations here in a second. Sketching a slope field. If given a differential equation, we can sketch a slope field at the indicated points by substituting in the x and y values into a given differential equation, okay? And so like an example of this would be, here's a differential equation. dx, oh my gosh. Man, you can tell this is the first lesson. So let's say, dy over dx is equal to x over y. So this is a slope, and I can calculate the slope of this by plugging in the x and the y value, okay? Very, very important to note, slopes on a slope field will never be undefined. So if there's a dot there, then you'll never have an undefined value. Usually what they do is they leave out the undefined values, and so we'll look at that, okay? So let's go ahead and kind of see how this works. So here's example number 1. They say consider the differential equation dy over dx is equal to 2y over x. First of all, note dy dx, this is a slope, right? Or this is a derivative. And so if you ever have to use that, just know that that's what it is. On the axis provided, sketch a slope field for the given differential equation at the 6 points indicated. Okay, so notice I have 6 here, 1, 2, 3, 4, 5, 6. And notice that on my y-axis, it is left out. Why would that be? Well, on these x values, right, your x values here are 0. So you have an undefined slope here. So notice they don't put the dots there. Okay, they just kind of leave that one out. So let's go ahead and do this. Dx is 2y over x. So what I'm going to do is I'm going to take this point right here, which is -1 comma +1, and we're going to plug it into our differential equation. Okay, so what we get, so dy dx is equal to 2 times 1 divided by -1, which gives us -2. So I have to draw a slope of -2 through that dot, okay? And so I'm going to go ahead and do that. And, kind of a trick that I do here is a slope of -2 would be down 2 over 1. So I kind of line it up with this point. I try to hit that target, okay? And that's all you're doing is just a little slope right there, okay? And then we can go ahead and do the same thing here for this value. This value is negative 1 comma 0. So dy dx here, if I plug in 2 times 0 divided by negative 1, that's going to be 0. So this is a flat, okay, slope field. Slope is 0. Okay, and then down here, next one, this point is negative 1 comma negative 1. So we'll get a pattern going here. We get 2 times negative 1, which is our y value, times negative 1, which is our x, divided by negative 1, which is our x value. So we get a positive 2. So this one's going up. Okay? We can do the same thing over here for these ones. So we'll take this point. So dy dx is equal to 2 times y, which is 1, divided by x, which is positive 1 this time. Okay? And hopefully here you notice, hey, my y value here is 0. So again, 2 times 0 is going to be 0 over 1, which is just 0. Okay, and so it seems tedious at first, but you do get quicker with it. Okay, and then dy dx here, 2 times negative 1 over a positive 1 gives us a negative 2. So like that. Okay, that's kind of the first idea that you're going to encounter for slope fields on an FRQ that they may ask you to sketch those points. Okay. All right, here is example number 2. Same idea, given the differential equation, y squared over x minus 1. On the axis provided, sketch a slope field for the given differential equation at the 10 points indicated. So I don't know if you would see one this large, but kind of the same idea here. Go ahead, please pause me, try it, and then I'll show you the solution here. Okay, so let's go ahead and look at this. Hopefully you got these values, but I also wanted to talk about some like patterns and kind of ways just to speed this along because like I said, it is tedious. I kind of put these in colors. So this first point has a value of 2. So 2 squared over 0 minus 1 is 4 over negative 1, which is negative 4. Okay, pretty steep. And then I also wanted to relate this. Notice how that's y squared. Well, if I plug in negative 2, that's going to be the same exact value. It's going to be 4 over negative 1. So this green slope and this green slope are exactly the same. And I also put these in green too, but because over here, notice my denominator is going to be a positive 1, right? It's x minus 1. So here we get a negative 1, but over here, 2 minus 1, right? We get a positive version. So all of these are going to be the positive versions of these. Same in the red, right? My y value is 1. So 1 squared divided by 0 minus 1 gives me negative 1. Okay, this slope will be exactly the same because I square that negative 1, but over here, my denominator is going to be positive, so I get the positive version. And then here, our y values are 0, so, you know, it's going to be 0. That's it, okay? That is sketching slope fields, okay? While the slope field from example 2 is drawn only at 10 points, it is defined at every point in the xy plane for which x does not equal 1. Describe all points in the xy plane where x is not equal to 1, for which dy dx is equal to negative 1. So let's look at this. I'm going to take my equation, so dy dx is equal to negative 1. Well, this means, right, I'm going to take this, this curve here, which was y squared over x minus 1 equal to negative 1. Which is going to in turn give us y squared is equal, if I multiply both sides by x minus 1, I get negative x minus 1, which would also be negative x plus 1. And then I'm going to take a square root here. So y is equal to plus or minus the square root of negative x plus 1. Okay? So at any point where x is not equal to 1, this will be our solution. So y would be equal to plus or minus the square root of negative x plus 1. Okay? And have that slope. Okay, your slope would be negative 1. So we'll go ahead and do the next part here, which is sketching solution curves. So the other thing in AP Calculus, what they'll go ahead and do is they'll give you a slope field, and you'll be asked to draw a solution through it. Couple of notes here. The solution curve must be a function. It must be a function, and this means that it has to pass the vertical line test. So don't draw any sideways, parabolas, any circles, anything that would violate the vertical line test. Don't draw those. Number 2, the solution curve must be continuous. If there's a vertical asymptote or other undefined value, the solution curve will stop. Okay. Number 3, the solution curve must pass through the indicated point. Must pass through. So if you don't pass through the point, then you know you're doing something wrong. Make the point bold so it is obvious when you're sketching it. Number 4, when possible, the solution curve should extend to the end of the slope field. Don't use arrows. So let's go ahead and look. Here's example 4. A portion of the slope field of the differential equation dy dx equals cosine of y is below. Sketch the solution curves through the points 2, 3 and 0, 0. So what I like to do right away is I like to plot a point on these. So 2, 3, I'm going to go up, and I believe it would be right here. That'd be 3. Okay, so there's my first point, and then 0, 0, we'll put right here. Okay, and so this is a slope field, and you can kind of see like movement, and it just generally tells you. So you just generally move with the curves. So notice my slope's telling me go this way, go this way, go this way, go this way. Okay, and then all of a sudden I see a flat line. Do not cross flat lines. That is a slope of 0. So my curve's going to go that way, and I have to extend both directions. So I did that one. Now I'm going to continue here to the right. Okay, and there we go. So as I move along, right, this is kind of telling you which direction to go. So don't egregiously cross these lines. You want to flow with it, okay? Be the water. Be the water. And then here's the second one. So I'm going to go ahead and just kind of flow. Okay, so same down here. I'm going to go ahead, not that, don't draw that. Oh my goodness. They really want to add that. So there you go. If you deviate, or if you're like above a line or below a line slightly, I don't think it's that big of a deal. But the main thing is do not cross any horizontal slopes. Extend from all the way from the left to the right. Okay? And that's how you draw a solution curve through a slope field. Just move with the slopes. The slope at that point is telling you what your line should be kind of sloped at, right? So if you look around it, notice that that's generally the slope of my line, right? So generally the slope, okay? And then I never cross the ones with 0. All right, here is example 5. This is the last one. I want you to pause me, try this, and then I'll show you kind of what I got here. Oh, and before you do that, something to note here. Do you guys see these vertical lines here on the x-axis? That's undefined slope. Do not cross that. So do not cross that line that is undefined. Okay, and I'll show you kind of what that looks like here. But go ahead, draw these two. Okay, here is the solution. So we have two curves, the point through 0, 2, and the point here from 3, -2. Note how on the 3, -2, how I have the open circle. That open circle is indicating undefined. So I don't extend this curve this direction because that would not pass the vertical line test. All right. So hopefully in this video you learned about slope fields, how to sketch them, and how to make them. Give this video a thumbs up if you learned something. See you in the next video.